original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Good evening and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and as the professor says, the darn good friends of York University. I will be one of your hosts this evening. My name is Kshitij, and I'm joined by Gagan.
Hi.
Say hi. Okay, and we have our dear professor to welcome us all into the new year.
G'day, folks. Hi there. It's Paul.
Okay, so, first, the honors. We're broadcasting live from the Alumni Carswell Observatory located at York University in Toronto, Ontario, Canada. And this is a Canadian astronomy night. The lineup is all Canadian. We'll start with ourselves, and then that's our York Universe. Move on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. Universal time for the Eastern Standard Time clock, or 1 a.m. Universal time for the Eastern Daylight Time. The York Universe production works in concert with our online public viewing program run by the observatory team, which runs between the hours of 9 p.m. to 10 p.m., which is right now, local Toronto time. You can go to observatory.info.yorku.ca and follow the links to OPV or the online public viewing and join the chat. Our broadcast is powered by and in partnership with astronomy.fm, the voice of astronomy. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory, and Facebook at Alumni Carswell OBS or OBS. All of our programs are free, but if you would like to make a donation, please see our website at observatory.info.yorku.ca. We will be monitoring the chat room for questions and to post content. And like I said, this was the honors part, or bringing us in part. How are you, Gagan, and how has the new year been for you?
It's been good. A little busy, but we've got some exciting news to talk about today, so I'm looking forward to that.
Oh, that we definitely have. In fact, the entire globe is actually talking about it, and I'm trying to dim the light of that thing. But anyways, that's a graduate student talking. And professor, usually it's you who brings everybody in, at least on my shows. So may I ask, may I suggest if you can talk about something which probably is worth talking before we start the show?
Well, the first clear night of the new year into the new academic term, the Alumni Carswell Observatory team and myself got really excited. We opened up the telescopes. We found our first bright stars. We focused. We were looking forward to a long, clear night. And in fact, the observatory team was going to image the James Webb Space Telescope. Yes, it's only a point of light, but that was the target for tonight. And then it snowed.
Yeah. You didn't tell us that. Oh,
yeah. So anyway, the night turned perilous and domes closed and people got out brooms and fans to blow the snow off the equipment. Oh, what can you say? Anyway, the first night of observing for any new year is always a challenge because, you're a little rusty, the equipment is a little rusty. We just didn't anticipate it to become a little snowy. Anyway, we're okay. We'll wait for another clear night, and the JWST will be in our sights, rest assured.
Well, let me be smug and say, welcome to Toronto winter.
Sums it up pretty well. Balmy minus 12 outside at the moment.
Oh, that's it? I thought it was minus 20. That's what I remember.
It is going down to that. At the moment, it's minus 12, but it's forecast to plummet to minus 17 tonight without wind chill down here in Toronto.
Honestly, my best wishes for everybody, and I hope everybody has a safe, nice New Year. Professor, I think you would probably take us away with the first item.
I can do that. Let me take you back in history. January 5, 1972. Yes, this was in and around the closing moments of the Apollo program. In fact, there would be 2 more flights to the moon in 1972, but by the close of 72, humans' engagement with the lunar surface will stop, or will have stopped. So, of course, the question was being asked, what next? And in fact, that question was asked by President Nixon in 1969, literally the day after Neil Armstrong set foot upon the moon. You know, been there, done that, sort of President Nixon thought, and he commissioned a group called the Space Task Group, and they had one, I won't say simple, but they had one chore: to figure out where NASA and the US would go after the Apollo moon landings. This was an important era, and I will argue that it was an opportunity missed. Nixon's era was fraught with challenge, and we won't even talk about Watergate in 1972, but in the late 1960s, early 1970s, the Vietnam War was raging. There were shall I say, racial instability across the US. It was a very challenging time for the US. And of course, that really meant that dollars were in short supply. And Nixon was never a big fan of the space program after the US beat the Russians to the moon. As I said, been there, done that seemed to be his attitude. And so the Apollo program, which was meant to run at least through Apollo 20, got scaled back to Apollo 17, cancelled unceremoniously. And with the only thing on the horizon being Skylab, the question was being asked, where next? The Space Task Group basically came forward with a series of very visionary activities, not the least of which was early space station, a space station around the moon, a lunar base, and the preliminary endeavors to go to Mars. None of them were approved by Nixon's administration. The one thing that the Space Task Group did suggest was a reusable system of vehicles that would allow access to space to be quick, easy, efficient, and cheap. Okay, well, what you're hearing me say is the genesis of the Space Transportation System, the STS system, which became known as the Space Shuttle. January 5, 1972 is when the task force recommendation was endorsed by Nixon and announced to the world. So the STS system became live, shall I say, January 5th, 1972. As I said, I would argue it was an opportunity missed. Even at that point in time, most space enthusiasts recognized that getting to the moon was the beginning, not the end, as far as NASA's exploration, manned human exploration of the cosmos was concerned. But unfortunately, that was not the view from the political side of the House. The STS did, in fact, come into fruition. They expected it to be launched in 78 to be fully operational with vehicles that would fly at least 100 times, potentially as much as once a week. They expected this to all happen by 1980. The reality was that Columbia didn't launch until April 12th of 1981. And at that point in time, of course, everybody began to realize that this reusable system wasn't going to be as cheap and as easy to accommodate as had originally anticipated. In many ways, the space shuttle really did not reach its full potential, and that was because, unfortunately, it was a very complicated system. Nonetheless, it did fly. It flew for 30 years. It gave us some wonderful opportunities in space, but how much more we could have had if the Space Task Group had many more of its recommendations crystallized into action as far as the U.S. government was concerned. Anyway, January 5, 1972, the announcement, in essence, of the Space Shuttle system and the demise of lunar exploration for 50 years.
So, if I can loosely say, as the amateur I am, no matter how much we actually talk about the STS program, the reason I keep remarking that I don't know why we talk about it and there is still so much that happened and yet nothing happened, that was my intuition being right. And my ignorance also being right because I never checked upon STS.
Well, I mean, the space shuttle had this pre-programmed activity of going round and round and round in low Earth orbit. That was never really its ultimate aim. It really was meant to give us very quick and relatively inexpensive access to space. On those counts, the STS system failed terribly. I mean, we ended up flying, generally speaking, on average about 5 times a year. That's about, once every 2 months. Even at the height of the shuttle program, we never flew more than 9 times in a given year, and more often, especially after the losses of Columbia and Challenger, we only flew 5 times a year. It was a great truck. It took the necessary material into orbit to build the International Space Station, but it was meant to be so much more, and it was meant to be part of a much bigger system, as I said, that would have seen not only a space station built and maintained in the 70s, but a space station in lunar orbit and a lunar base. And that could have all happened by 1980. And instead, we are talking about a return to the moon with humans in 2024 or 2025. Opportunity missed, and I will be uncharitable and lay it at the feet of Nixon, but that is not necessarily completely accurate. But it is a off-the-cuff remark which bears some scrutiny.
I guess, in a way, it's kind of like they wanted the space shuttle missions to be what SpaceX has now, but I guess right. It was about 40 years too early.
Sums it up pretty well. That's a good observation, Gagan. I mean, Elon Musk and SpaceX have largely done what they wanted the space shuttle to do, but they just weren't prepared to go down that pathway as far as they needed to. They made a decision early on that the external tank would be discarded, that would not be reusable. And if you look at it, that was basically the biggest piece of the space shuttle system. The 2 solid rocket boosters were reusable. That was good. The shuttle itself was reusable, but far too complicated to turn it around in the matter of days to weeks, whereas SpaceX has, I believe, turned one booster around within a week to fly again. That's what their ultimate aim is. They don't normally do that, but they have shown that they can do it. So, SpaceX happened 40 years after the space shuttle, and the space shuttle was supposed to be what SpaceX does now.
Well, I know we can't dwell too much on it, but I'm kind of sensing maybe I read somewhere that the biggies who used to handle NASA's missions, for example, Boeing and the other people, they could have done this, and it is said that SpaceX could do this better because they really did bring down the costs and I don't know, whatever. But it's just my 2 cents again. Since we shouldn't probably be dwelling too much on the same idea, and let's talk about something which was actually much more successful and way, way far back in history than 1972. So, Gagan, you have an interesting piece to talk about.
I do. So this past week was the 412th anniversary of the discovery or the first observation of the Galilean moons. You can probably guess they were discovered by Galileo. Of course, they weren't called the Galilean moons back then. Their discovery did, however, play a huge part in astronomers' understanding of our solar system at the time. On the night of January 7th, using a homemade refractor telescope with only a power of 20, I believe, Galileo discovered what he called 3 quote-unquote fixed stars around Jupiter. And he later discovered a 4th body a few days afterwards and continued observing these stars for the next several weeks. Over this time, he noted that while the bodies were not fixed, they were also not moving appropriately relative to the background stars, and instead appeared to move in orbit around Jupiter. This was a huge discovery because at the time, the Ptolemaic geocentric model was the most popular and widely accepted model of the solar system. And the model states that all bodies in the universe or the solar system revolve around the Earth. But if smaller satellite bodies were shown to orbit a more massive Jupiter instead of Earth, then who's to say that the smaller planets of the solar system couldn't orbit the more massive sun? And so this really didn't coincide very well with the widely accepted geocentric model. And Galileo himself was a proponent of the Copernican heliocentric model with the sun in the middle. And this would land him in hot water a little later and actually lead him to be charged with heresy. But it was also noted that Kepler's laws of motion, which describe the motion of the planets in the sky, they were published around the same time as this observation by Galileo. A few decades after this discovery, Kepler and a couple of other astronomers observed that the Galilean moons followed Kepler's laws of planetary motion in orbit around Jupiter. The moons were eventually named Ganymede, Europa, Io, and Callisto, chosen by Simon Marius, who is another astronomer, observed the moons at the exact same time as Galileo, basically, I think within 3 days, but he didn't publish his findings until a lot later. And in the end, Galileo's discovery would prove to be a major contribution to our understanding of the solar system.
Hard to believe that that was over 400 years ago. We all take observing with telescopes for granted, and so we should, because we've all grown up with it. But there was a time once where looking through a telescope revealed absolutely brand new vistas. And this is one of those classic ones, looking at the planet Jupiter and identifying the satellites that were orbiting around it and realizing that they were satellites of Jupiter. Big, big step forward as far as science was concerned.
For sure.
The only thing, right, and just to add to the entire story, the theme, I think I read way back, even before I started studying again, that Galileo, when he was tried, he ended up muttering later on that, but it does move, something like that. It was in Italian, so I don't remember the exact verbiage. But I think his trial was really a personification of his whole story in itself.
He was very defiant. He was very assured of his own view in this regard, which was backed up by observation. But it was a fairly classic example of experimental observation and theology running against each other and not wanting to see eye to eye. There's certainly more to the story associated with Galileo and his conflict with the church, but the bottom line from our point of view is that he was the ultimate observer. He was able to take very rudimentary equipment and come up with great insights with respect to what he saw, and that was that's the classic trademark of a great observer.
Absolutely.
Yeah, and that story about his trial, I looked into it actually for This Week in History news article, or not article, but news segment, I believe last year. And I just have to say, if you go into the original source work that he wrote, I believe it was Dialogues on the Two Worldviews, that source material is possibly the funniest thing that the Catholic Church could have gotten upset over. It is so entertaining to read about it after the fact, and they were so upset about what he said, and that became such a popular book they had to ban publishing. It was a scandal.
Sad, in many ways, very, very sad. Unfortunately, he didn't sort of live to see the fruits of his labor, shall we say. I mean, eventually he was vindicated from a scientific perspective. And back in 1992, the Catholic Church, 1992, like nearly 400 years later, they put all of his books back on the you can read it list. I mean, it's, as you say, Gagan, it's a little humorous, but it's also sad.
Definitely.
Okay, I will not let us be sad anymore. I will move on to my own news item. Sorry, not news item. The item for This Week in History, the third one. I will be talking about this particular era, which we're living in. And the year was 1959, January 2nd. And I'm talking about Luna 1. I'm not sure how many of us actually remember that mission at all, or, probably even once in a year. But every time I read about it, I really really get impressed for I don't know what reason. So this was a launch done by the USSR, which was back then, and now it is known as Russia, more or less. It became the first spacecraft ever to reach the vicinity of the moon. I'm hoping that's the right expression. And that basically means it was 5,900 kilometers. That was the closest approach in that dark, empty space, which is not more than 1.5 times the moon's diameter. And it probably was not a big deal based on what we were back then as humans' technologies. But it missed the target, reportedly due to an error in the upper rocket's burn time. Talk about errors. And whoever is listening and does not take care of errors properly, please do so. However, it still gets the credit for the first and perhaps the only artificial planet. I'm not sure if that's correct or not, but that's what Wikipedia says. So it was named Artificial Planet 1 since its positioning in a heliocentric orbit was made possible because of whatever error happened. And of course, it's not geocentric, it's heliocentric. Due to the nature and the results of the entire mission, perhaps, it was then renamed Mechta, which means dream in Russian. It was also the first to transcend Earth's escape velocity. So they also call it the first cosmic ship. It was basically a spherical satellite or a ball with mercury oxide batteries, 5 antennas on the little ball, radio and telemetry equipment, of course, surprise, along with a tracking transmitter. And it may be worthy to know that there was no propulsion system on that spherical thing which they launched into that empty space, cold, dark space. I really pity the ball. It was a slingshot at best. And the equipment on board include Geiger counters, scintillation counter, and even a Cherenkov radiation detector. It weighs, and the reason I'm saying weighs is because it still exists right in front of our eyes, an odd 361.3 kilograms. I'm mentioning specifically because it's a specific number. And it has since then orbited the sun 56 times till 2020. That's the last data that I have, putting the orbital period at roughly 450 days. So we actually do not have 8 planets in the solar system. We actually do have 9 planets in the solar system, no matter what we did to Pluto's reputation.
I was going to say, opening up a can of worms. Yeah, right. Okay, I'll go with it was the first artificial satellite to orbit the sun. I'm not going to go with it being a planet under any definition that I care to think of. But yeah, I can understand why the term was used back in 1959 or thereabouts, artificial planet 1. But certainly our first heliocentric orbiting artificial satellite.
Yes, and I think if I can request, you can take on the next item, because I've rambled enough already.
The moon is always a good place to ramble about. Well, speaking of the moon, okay, let me follow up on this. This is just a few years prior to the Soviet Union's Luna 1 mission. The moon, of course, is a big object and it was exciting and so on. But back in 1946, we didn't really have aspirations of getting to the moon. But, or at least getting to the moon with respect to satellites, with respect to human beings. But there was a project that decided that using the moon as a target was a really good idea. On January 10th, 1946, from a spot in New Jersey, the first radar pulse was actually bounced off the moon. Now, anybody who's watched The Big Bang Show knows full well that those nerdy physicists can do that from their backyard these days. Back in 1946, it wasn't nearly so clear that that was a possibility. So the Army Corps of Engineers was basically tasked with determining the properties of the ionosphere, whether or not they could track missiles flying through the ionosphere. Remember, this is just at the end of World War II, and the German V-2 rocket technology was now being distributed between the Soviet Union and the United States, and so the era of thinking about death from above was really gripping everybody. And so the Army Corps of Engineers was tasked with basically figuring out whether or not you could pass radio communications, radar through the ionosphere. I know it sounds strange now because we do it, of course, without blinking. But back in 1946, they didn't know whether or not you could penetrate the ionosphere. And so Project Diana was born. Diana is the Greek goddess for the moon, by the way. Nothing to do with any other Diana you might be thinking about. But Project Diana was tasked with bouncing a radar pulse off the moon. Now, this was, of course, before the age of Apollo. This has not got any radar reflectors on the surface of the moon. Basically, we were charging a very big pulse, bouncing it off the moon and trying to detect the return pulse. And of course, that return pulse did come back 2.5 seconds later, the travel time from here to the moon and back, moving at 300,000 kilometers a second. It was successful. So not only had these folks proved that you could actually penetrate the ionosphere, but they also did the first lunar bouncing. Take a signal, bounce it off the moon, do the appropriate calculations for the Doppler shift because everything is moving, the moon is moving, so the pulse frequency gets modified. They were able to do all of that, and the first successful detection of that return pulse was January 10th, 1946. Basically, it was the birth of radar astronomy. That, of course, was just the first step. We are now far more familiar with bouncing radar signals off Venus, bouncing radar signals off Mercury, determining some rudimentary surface features, but more importantly, determining the actual rotation rates of those two planets. At the era of the 1950s, 60s, even into the 1970s, really, really tough to figure out how rapidly Venus and Mercury rotated. And so we utilized radar astronomy to actually make those calculations, and they did it very, very successfully. We've also used it for extensive mapping of the shapes, sizes, and so on of near-Earth asteroids. So radar astronomy is alive and well. The Arecibo Observatory, rest in peace, was certainly one of the primary antennas on the Earth that was utilizing radar astronomy. And of course, once we put reflectors on the moon, we started bouncing lasers. I know that's not radar, but it's the same basic principle, utilizing electromagnetic radiation, bounce it off the surface of the moon, and we can ever so accurately, like down to centimeters, measure the Earth-Moon distance and therefore better characterize the moon's orbit. And from that, we've been able to determine that the moon is steadily moving away from the Earth, courtesy of the Earth's rotation slowdown and the conservation of angular momentum, pushing the moon further away. We've actually now measured that, and it all comes down to this original pivotal observation on January 10th, 1946.
I cannot add anything to that, probably because I've never read about it as much.
It's a really interesting story. I mean, there are all sorts of firsts. I mean, Gagin just mentioned the first observations of the Galilean satellites and how that led to other observations of planetary objects, et cetera, et cetera, et cetera. Well, this was another first, the first radar observation. Interestingly enough, the space.com talks about this day in space history themselves, and they referred to this particular event as the birth of radio astronomy. Tusk.
Right.
Not true.
Not
Jansky,
true. Yeah, I was with that.
That's right. Jansky and company had sorted out radio astronomy nearly 10 years earlier, but this was the first observation with radar astronomy.
Well, so much for the moon, and I guess I am just pressed by time because that's the only reason I can give valid.
Yep. Move us along. Move us along.
Yes, sir. Well, Duggan, you would like to talk about something even more phenomenal, probably?
Are we moving into news stories, or is this still the history item?
Oh, just the history item that you have lined up for yourself.
Okay, I was going to say, because we have, we're staying on topic today because I have another moon for us.
Don't worry about
it.
but just not the moon.
Not the moon, a moon. One of many. So this week in history marks 17 years since the Huygens probe landed on Saturn's moon Titan. The Cassini-Huygens mission is one of the greatest successful missions in recent space travel history, and I know I'm not alone in considering it one of my personal favorites. I'm sure I'm not even alone in this radio meeting considering it a personal favorite. It was just that great. So this mission sent a probe, Cassini, to orbit Saturn and observe its atmosphere as well as its moons and rings, or should I say satellites and rings. And it also launched a lander, Huygens, which was deployed to Saturn's largest moon, Titan. The lander was named for the Dutch astronomer Christian Huygens, who discovered Titan in 1655. The mission launched in 1997 and arrived at Saturn 7 years later in 2004. On January 14th, 2005, about 6 months after it arrived at Saturn, Cassini successfully deployed Huygens and it landed on Titan, and it became the first craft to ever land on a moon orbiting another planet. Because we had done our moon several times at that point. So Titan has been considered a super interesting moon in our solar system for several reasons, including its nitrogen-rich and extremely thick atmosphere, and its hydrocarbon lakes, which are it was a group of suspected bodies of a hydrocarbon liquid that's a stable liquid that are present on the surface. So Huygens was able to transmit images and data from Titan's surface back to Cassini and Earth, and further observation by Cassini and Huygens confirmed the presence of sizable hydrocarbon lakes on the surface, comparable in size actually to some of the North American Great Lakes, and one of them was actually named after Lake Ontario. So Huygens only transmitted data from the surface of Titan for a really short period of time. It was under an hour, so the battery life of Huygens was only meant to be about 3 hours in nominal conditions, and 2.5 of those hours were spent getting Huygens to the surface of Titan, so they didn't have a lot left to work with. But what they did get in those 30 minutes was a lot of useful information. Huygens recorded surface temperature, pressure, and humidity, and the photos it sent back show the terrain around the landing site. And another fun fact I discovered while looking into the Huygens mission, I don't know if we have a lot of Dune fans listening or if either of you are big Dune fans, but most of the planes or planishes on Titan are named after planets from the series by Frank Herbert. So there's an Arrakis planisha and a bunch of others that are all named after planets from Dune.
I had not realized that. Yes. I won't tell you when I first read Dune because neither of you were born at that point. But yes, I am a big Frank Herbert Dune fan. Not necessarily the movies, by the way. But yes, the book was phenomenal. I had not realized, Gagan, that a lot of the nomenclature on the surface was named after, the books. I will now go back and have a look at my my Titan topography.
Yeah, I'm going through the book right now because I just watched the movie. I enjoyed the movie when I watched it. So the more recent one. So I got the book and I'm making my way through it. And the only one I recognized so far was Arrakis. But it was enough for me to click on it. And then it said, yeah, these are all the other planetians that are named after Dune planets.
I'd stop after the first book, by the way.
Oh, right after the first one?
Yeah, I would, but anyway, it's a debatable point.
That's for another episode.
Yeah, I mean, it's a trilogy in 5 parts, and it was meant to be one book, okay? And yeah, anyway, we won't go there, otherwise Shatish will start yelling at us.
Actually, I would not, and I just have one thing to say, and this is probably the biggest surprise, and it's a New Year surprise. To quote Shakespeare indirectly and try to pronounce it properly, so it probably says A2, Professor?
A2. Well, better
too?
Professor than Brutus.
Well, that does at least mark almost, actually, we're over the half-hour mark for the show, so those of you who have just joined us, you're listening to York Universe, broadcasting live from the Allen I Carswell Observatory, located at York University in Toronto, Ontario, in Canada, in Canada. And you're listening to myself, Kshitij, along with Gagan, and Professor Paul Delaney. And we were just talking about Dune. Well, actually, we're talking about Titan.
Titan, yes.
But we finally did end up talking about Dune. So I'm not sure if I can break protocol, but I think, Professor, maybe you probably would like to talk about the reminders first. And
I can do that. Absolutely. As always, just because it's a new year doesn't mean that things have changed too terribly much. Every Wednesday night we have our Teletube Wednesday, so 7:30 to 8:30. The observatory team brings you what's latest and greatest in the world of astronomy. They put together a terrific presentation, live views from the 1-meter telescope, if of course the clouds will part, and all of this is on our YouTube channel. So if you pop across to YouTube, Alan I. Carswell Observatory or York University Observatory. Either of those will get you to our live streaming link. If you want to whet your appetite for the coming Wednesday presentation, we have got lots and lots of past shows, a year and a half's worth now. Thank you very much, COVID. So there's lots and lots of terrific stuff that you can catch up on from the observatory team. But Teletube, Telescope, YouTube on Wednesdays, 7:30 till 8:30.
Well, that is probably the most interesting thing, trust me, for those of you who actually do go to the Teletube Wednesday. The reason I'm saying this is because I haven't done that yet. So, I'm lying because I don't know. Anyways, I'll stop talking about what's not relevant. I will quickly try to usher us into the thing, which is probably the elephant in the room for today and for the past 2 weeks. So I would quickly first, talk about all sorts of space-based telescopes. Just do a recap. We had the first space telescope in 1959, which was, the acronym is OAO2, and that was Arthur Codd. And the first, or the most important thing it can be remembered for is the stellar explosions called Novae were discovered through that telescope. After that was Hubble, 1990. It is, of course, known for the Hubble Deep Field and Ultra Deep Field surveys, and doing work on primordial black hole understanding. That was followed by Compton Gamma Ray Observatory in 1991, which was 9 years. Later, I think. Well, actually, no, not 9 years, but anyway. So it
ran for 9 years.
It ran for 9 years. You should do your notes properly, as in I should, of course. That's what I mean. All Sky Gamma Ray, and this was 17 tons. It was probably the heaviest payload up until then, maybe, or maybe the heaviest of all ever. It detected gamma rays from thunderstorms on Earth. Also, a new class of galaxies, which were powered by supermassive black holes, and that also includes us. And that was a surprise. Then we had the Chandra X-ray Observatory in 1999, which was built to study quasars and neutron stars, amongst, of course, loads of other entities. And it did discover hidden black holes, including, again, our very own Sagittarius A. Then 2003 was Spitzer, and it really marked an era of exoplanet discoveries. It discovered IR radiation from faraway entities, and also accidentally, that's when it discovered TRAPPIST-1, which is probably the first discovered exoplanet system, which Professor can really talk about very well. You can talk about anything, of course. And it also used the microlensing technique, discovering dead stars and more exoplanets. This was followed by Kepler in 2009. I'm sure we've heard the name. It was designed to hunt for planets, and it used the light dipping method, telling us that there are more planets than stars in our galaxies. I think the light dipping method simply talks about the transit method. And Kepler discovered around 2,600 exoplanets during its operation.
And counting.
Am I correct?
Yes, and counting.
Okay. Yeah. Well, we do good things. And then, the last of this list is probably Fermi, which was previously known or named as GLAST. And that also was 2009, which was supposed to take over Spitzer's remaining tasks. It also is a gamma ray focused telescope, and it detected the strongest gamma ray burst, GRB 1.4, I think. That's known to us so far. And GRBs have since become a sensation in the field of astronomy research. And with that, I think I could just leave the floor open to both of you to talk about, like I said, the elephant, and please name the elephant, whoever wants to go first. So it's a beautiful thing.
Well, before Gagan launches into the James Webb Space Telescope, because that is, as you say, the elephant in the room, but such a beautiful elephant. One thought with respect to the observatories, you've hit the highlights, no question in the world about that, but let us not leave the impression that these have been the only space-based observatories, because that is not the case. There have been probably 2 to 3 times the number that Satish has gone through of space-based observatories from the 1960s right through to the current day. We've had a number of solar observatories, of course, that have monitored the sun almost continuously over the last 30 years. We've had ultraviolet satellites, in particular the one that I did my master's thesis on, the International Ultraviolet Explorer, which was launched in 1978.
Oh,
Yeah, I got to put that in. Absolutely. It just shows how ancient I
missed
am.
that.
Yep. And of course, then there's a plethora of other X-ray telescopes. So the list you gave, Satish, just fine. It certainly is arguably the largest, the most important, but let us not leave the impression that they are the only space-based observatories, because that is not the case. There have been a huge number that have taken advantage of the space environment to do some terrific observations, and in fact observations that are just impossible from the surface of the Earth, courtesy of the atmospheric windows that our atmosphere allows. So that said, Gagan, the elephant in the room, it's all yours.
Awesome. Okay, I want to take a deep breath before I start because I wrote out a really long spiel about this. So, buckle in, everyone. The time has finally come. This is probably the one news story I think I've been waiting to break for almost 10 years, but long predating my time with York
Wow.
Universe. So, on December 25th, 2021, after almost 26 years of planning, development, delays, more development, and even more delays, the James Webb Space Telescope finally launched. Now, allow me to begin with a little background. The James Webb Space Telescope is an extremely large space telescope, or should I say space observatory, because it's huge. It was initially proposed in 1996 as a next-generation telescope and conceived as Hubble's successor. Although Hubble's great success and longevity has allowed for a really long developmental period for the Webb. And I'll be calling the James Webb Space Telescope the Webb for short, just because it's a little bit of a mouthful. So some early delays and cost increases caused the James Webb Space Telescope's construction to lag quite a bit, and it was even almost canceled in 2011. But the Webb was finally assembled in full in 2016 before it underwent additional rounds of testing and system improvements pre-launch. The launch itself was delayed again a few times for various reasons, namely the need for further testing of both the mirrors and the heat shield, as well as complications that arose due to the obvious COVID-19 pandemic. In the end, the mission ended up totaling over 9.7 billion US dollars, billion with a B, so that's 9 zeros after that. And that was $9.2 billion more than what NASA originally intended the mission to cost. So they overshot their margins.
Now, you just stop there for a second and let that sink in for everybody. If you gave a projection for your lab, Gagan, that said a certain piece of equipment and a certain experiment was going to cost X, and you ended up charging the department 10X, can you imagine where your next paycheck is going to come from? And it's not going to be the department. I mean,
no.
It's stunning, that overrun. It really is. Anyway, sorry. I just...
Yeah.
Wow.
I truly can't imagine. That's more dollars than there are people on Earth. That's how much NASA overspent. Or not NASA, but you know what? I think it might have been worth it.
We're going to go with that. Carry on.
Let's go with it. So the telescope itself consists of a massive tennis court-sized heat shield that sits underneath a composite mirror formed from 18 hexagonal gold-coated beryllium mirrors. And these mirrors form a total diameter of 6.5 meters, or over 21 feet. The telescope will operate largely using infrared light, which requires a really cold environment. So the heat shield is super important to protect the scope from heating by the sun and light from the sun, basically. So while Hubble remains in orbit around the Earth and can be docked to the ISS for repairs, the Webb will actually be stationed at Lagrange Point 2, or L2, which is a region of space 1.5 million kilometers from the Earth, where it will remain in orbit. This distance, in short, means no repair missions. And this is a large part of why all those delays occurred. The JWST team really only had one shot to get everything right. And compared to the Hubble, the Webb is gigantic. So this was a really big mission. Like I said, $9.7 billion US at stake. So they could not afford to have a premature launch and, have an early disaster. So, like I said, the Webb is much bigger than the Hubble, and the primary mirror totals over 25 square meters in light collecting area, and the Hubble, in contrast, only has about 4.5 square meters. The Webb is therefore a much more powerful telescope than the Hubble, and it will be able to look back into space and gather light from some of the earliest galaxies ever formed. And this will provide us incredible insight into the universe's early days and its early formation days, which up till now we've only really been able to see, or not see, but we've only been able to theoretically conceive, if I may. The launch was finally scheduled for December 24th, 2021, when the Webb will be sent out atop an Ariane 5 rocket. Setup commenced weeks ahead of the big day at the launch pad in French Guiana in South America. However, inclement weather caused the launch to be delayed again, but this time, thankfully, only by a single day. After 26 years of waiting, the Webb finally tasted fresh space, and NASA described the launch as a flawless launch, with every single part of the launch and early deployment stages being executed perfectly. So these
That's
early
the dollars
deployments,
right there.
yeah,
So-
that's where all the money went. No worries. So right after the initial launch, the rocket set course, and it actually detached from the telescope within the first few stages of the launch. And following this, the heat shield and mirrors were unfolded, and the telescope took full form on its way to L2. It will take approximately 30 days to reach L2, and the engineers working on the Webb are basically calling it 30 straight days of anxiety and terror. And I don't know if I can relate to the extent that they can relate, but I can relate a little bit. At L2, it will undergo 5 months of calibration and alignment before it begins to transmit its first images back to Earth. And this is when the science mission really begins and where we really start to have some fun with it. NASA expects the telescope to last at least 5 to 10 years. However, the launch was apparently executed so perfectly that the telescope was able to conserve fuel from the realignment, and engineers expect the fuel aboard the scope to last about 10 extra years. So it should last about 20 years. This mission has been a really long time in the making. With the launch now in the rearview mirror, all we have to do is wait and see how the images come back, which I think is going to be the most exciting part about all of this, is getting that first image back from the Webb telescope. I'm sure we'll be back on the radio show to talk about whatever image that may be. And hopefully we'll see some stunning images of deep space. And one of the images I'd really like to see is a deep field image. I'm not sure if they'll attempt that within the first few months of Webb's operation or science mission. And I know imaging time on the Webb is very, very hard to come by. But stay tuned, because we'll definitely be here talking about it when we do see some images.
In fact, before we let Shadish add to the information about JWST, but talking about more insight into it, one of the guaranteed time observers, I mean, Canada has about 5% of the time associated with the JWST, which it might sound small, but it's huge because the other 95% is basically from the US. So we get 5% of the time guaranteed, and there are astronomers from all across the country who will be involved in this, including our own Adam Muzzin from York. He is one of those guaranteed observers, and of course, Sana, one of our radio hosts, is his student. Talk about her being excited. Absolutely. So we're going to try and gently twist Adam's arm in the next couple of weeks to come on and talk about his early observations, his observations of the early universe, galaxy clusters, and just to talk a bit about Canada's involvement, the observations that we are going to make. This is a telescope that could potentially revolutionize so many areas of astronomy because of the reach that it has, the capabilities that it has. And we're not equipped to talk about that here other than just in general platitudes, but Adam will be able to give us some really inside scoop as far as what they are expecting to see as far as JWST is concerned. So anyway, stay tuned. I've got to do a little bit of arm twisting in the next day or so, but hopefully Adam can join us very soon.
Well, actually, Professor, I was about to ask you if we should even mention that. And, well, I mean, I wanted to mention that, so thank you so much for bringing that up, because I don't know why even I'm excited. That does not mean I'm not excited otherwise. But because we have, like, I'm trying to sort of move to the question that I had, or one of the many questions, to give a little background as to why I'm even thinking of asking this question, or putting at least one of the questions is, just like Gagan said, she could relate to the anxiety and the terror or whatever. On the same lines, and of course, much more muted or much more dull, I can relate to the idea of a telescope not working and a student freaking out. Very small example. So when the 1 meter was functional the first time, and I was part of one of the sessions, and the petals didn't close. I think you were somewhere around, but you were not in the dome at that time. And then everybody probably panicked. Sana was there. And then I think the telescope did go offline, or, was put to halt for at least a day to even understand why the petals didn't close. And we were following the list or whatever. And to add to that, what I'm saying is I also did a little project on understanding the ground-based observatories, one of the few which is coming up in the future, the largest ones. The Large Synoptic Survey Telescope is what I wrote about. And I kind of have a very dim perspective now of understanding these two things in the matter as to how JWST could have been postponed over and over again. And when it comes to deploying a telescope, because I was trying to listen into the deployment live telecast today as well, I think it can be very, very scary for the team. And one of the questions that probably will be immediately relevant is, and that's what I'm trying to ask you, is the moving parts in a telescope. That's probably the simplest thing we can talk about. In terms of a space telescope, how difficult can that be in terms of the temperature changes? And I heard they'll use lubricants of different variety. So if you could, explain any of that to us, I think it would be worth the time.
So I actually did a little bit of reading on this stuff today as well. And there are a bunch of different things that go into any launch, of course. The $9.7 billion weren't just, coffee money for all the engineers. There was a lot that went into it. And one of the major things about the Webb that took so long to test and so long to engineer and manufacture perfectly was the primary mirror. In most telescopes that we have in the past, such as the Hubble, our own 1 meter telescope, the primary mirror is a single mirror, whereas in the James Webb Space Telescope, it's composed of 18 individual mirror sections that have to all align perfectly in order for images to come back as one cohesive image and not just like a mishmash collage of stars. So
Mhm.
that's one of the big things that the next 5 months will take up for alignment, is the mirror alignment. And they'll be doing testing to make sure that all the mirrors are aligned so that the images come out well. And another thing that you mentioned was the temperature of the observatory.
Mhm.
So because the James Webb operates in infrared light wavelength ranges, it has to be a lot colder than a light telescope normally would be. And part of the reason that it'll take 5 months for the images to come back is because when the heat shield gets deployed and in position in front of the telescope, or sorry, between the telescope and the sun, it's going to take that long to cool it down to the temperature that they want. And I can't remember the exact temperature.
Minus
But,
225 Celsius.
Yeah, that's about
Yes.
as close to, that's, insanely close to absolute zero. So
That's right.
that's,
If you have a look at the NASA website at the moment, they've got basically thermometers on the telescope, and you can see that it's actually cruising down to about minus 200 at the moment. The heat shield, the sunshade, has been deployed, so the telescope is now permanently in the shade. But as you say, it's going to take several months for it to come to equilibrium to a temperature that will be of order minus 225. That's the optimum temperature they want it to sit at to operate in the mode that they are expecting it to. But yeah, when you're talking about those cold temperatures, I mean, we've all had occasion to play with lubricants, and lubricants tend to, stiffen up as you get colder. And we're talking about minus 10, minus 20, minus 30, not minus 220, 230. So yeah, the engineering that has gone into this telescope, just from the lubricants perspective, is really quite unique and is quite exceptional. They've got a lot of little heaters on various latch points and on motors to make sure that they do not basically stall out because of temperature. The amount of detail that has been required for the simple things, and I say simple in quotes, tensioning of the sunshade and so on. You don't want the motors to overstress that literally micron thin mylar as it is pulling material outwards, so it's nice and stiff. And there is no shortage of books that are going to be written, engineering books that are going to be written about the construction of the Webb telescope. It really is an engineering marvel. And as we're speaking, to the best of my understanding, almost every single deployment mechanism that was required to work has worked. And now the Webb team is simply looking at instrumentation. So it's really gone picture perfect. And we say again, $9 billion and counting. It's looking as if it was all well worth the effort and the time and the money spent.
Yeah, and before we continue, sorry, I just wanted to make a quick note again about we were talking about the different things we use as lubricants in space. I don't know if either of you are familiar. I mean, you probably are familiar with cold welding, where past spacecraft have had problems where instrumentation will stop working completely because if two surfaces made of the same metal touch each other in a vacuum and they have nothing in between them, they'll just seal together because technically they're the same thing. So lubricant is super important for telescopes.
Well, I can quickly say it's humbling to say the least. And we are, of course, approaching the top of the hour. And wish everybody again a very happy New Year and a very happy James Webb Telescope, to say so. You've been listening to York Universe, the astronomy and astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been myself, Kshitij, Professor Paul Delaney, and David. And stay tuned because it's Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western World, and Science for the People.